Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
In the early days of development, configuring an application for deployment was a huge amount of work and was often encapsulated in installation programs that were complicated, error-prone, and could often destabilize other applications on the machine. In more modern software development, we've started to use container technology to fix these old problems, as well as to deal with some of the new ones. In this episode, we'll be discussing container technology from a high-level view so that you can understand why you might want to use containers to solve a lot of modern DevOps issues, while avoiding the DevOps issues of the past. But before we get started, Will, what's been containing you this week?
Well, obviously, I have done a deep dive on Docker. I initially ran into a problem on my NAS a few weeks back where stuff was not getting synchronized to it, which meant that it wasn't in the backup set. And to troubleshoot that, I had to kind of figure out some things on Docker that I hadn't really learned. And as I continued messing with it, the light bulb started really coming on this stuff. And, like what I could actually do with it, especially now that it's more stable. Like I looked at it a long time ago when it didn't work on Windows at all. And it had some funky things going on, like performance wise and all that on Linux. And so I hadn't really dug into it. And so now I'm trying to get a build server set up. I'm trying to get Postgres working on there. I've got a bunch of stuff I want to do and just experiment. And I went from just the regular Docker install of my Synology to Protainer, which is a Docker container management tool. And so I can do Docker stacks, like with the declarative builds and all that kind of stuff. It's really neat. So I've been playing with that. In addition, the company that I'm contracting with approached me about a senior developer position full-time with them, and I accepted the offer, and my first official day is Monday.
Awesome. Congrats, man. That's wonderful. I mean, I say that like I didn't already know that, but Yeah,
well, I mean, you've been hearing me for like the last 6 months going, I know it's coming. I hope it's coming. So it came. So
I know you really like working there, and we're hoping to get on full-time, or not full-time. You're already full-time, I guess permanent. Yeah, that's the...
Yeah. Like, like you're a real employee instead of the contractor, even though they don't really have much of a separation there. There's going to be some inevitably.
A real employee as opposed to a Pinocchio employee.
Right. Whose timesheet just grows. Yeah. That said, I'm in paperwork purgatory right now because you got to do all this stuff, and you got a drug test, and I've got to do the exit thing for the previous gig and all this other stuff. So there's a lot of back and forth, but it's all supposed to be done by Monday. I also have to burn PTO time from the previous gig because I can't get paid for it and it doesn't transfer. So like that's the other thing with this Docker stuff. I really don't need to do this right now, but I needed something to do. And it was just like, okay, all right, you know what? I'll make the perfect setup for me and play with this. This will be fun. So yeah, that's kind of what is happening there. So how about you?
Well, I jumped out of an airplane this weekend. That was a rush, literally. We got up to about 150 miles per hour in free fall. That was really cool. I'm not sure which part I liked the best, though. The free fall or the float down after the parachute opened. It was really cool. Like, free fall was a rush. The only issue I had with it was they didn't tell me about the breathing, because, you have like air flying into you. And so they call them quarter breaths, where you just take like short, shallow breaths, and that fills your lungs.
Yeah. Because it's pressurized.
Yeah. And because it's just like forcing it back into you. And so, I figured that one out on my own. I think they don't tell you because you just figure that out. That wouldn't have been a problem, except that my right contact fell out in free fall.
Well, you can't go look for it on the ground. I'm just gonna
Well,
throw that out
I
there.
was wearing goggles,
Oh,
so it landed in the goggles, and the place where I went was it's about 30-minute drive from my place. We get to the ground, and that's when I actually noticed. I'm like, wait, like the rush is kind of like coming down. I'm like, all right, wait, what's going on? I can't see my periphery very well because I'm left eye dominant, so like that took over, but like just my right periphery. I'm like, and that's when I realized my contact was out, and I found it in the goggles. So we get back, and I was asking, nobody had any contact solution. So I drove over to Walmart there in the town there, bought some contact solution, and of course the contact like hardened because it had been there so long. So I had to drive home with only one contact. That honestly I think was more dangerous than the actual skydiving. Not really. I could see perfectly fine. It was just like the far right.
you have to turn your head all the time.
Yeah, if I needed to look behind me or anything like that. Turn my head, like turn my whole body basically to do that. So I do find it very funny. Lots of people liked and loved the story I posted before I went, saying that I was like when I was there, saying that I was jumping, but only one person liked the after story saying I survived. And no, it wasn't Amanda. She didn't like the first one either. She's in Ecuador on her mission trip right now. So I did see that some of the people, I don't even know if she's got her phone with her because she hasn't posted anything, but I've seen other people who are there posted pictures of her. So I'm guessing she's seen it. I don't know.
She'll get a kick out of the story of you coming back doing your Nick Fury impersonation.
Yeah,
road.
Yeah. So it is a lab week at work. Basically, this is a week to work on side projects or learning something new. So I'm working with a friend to build a planning poker app for one of our Scrum Masters. This started as we were wanting to get together and build an app to do learn, practice, whatever cloud deployment, but we needed an app, and he had been asking for someone to build this, and no one jumped on it. So we're like, all right, well, we'll build it and use it for our cloud deployment. So I've been playing around with that. It's fun, but I had forgotten how annoying JavaScript can be because TypeScript has spoiled me, to be honest with you. Like, we're building the back end with Node for it because it's just a proof of concept kind of thing. And yeah, TypeScript's annoying.
You mean JavaScript is? Well, TypeScript is too in its own way.
Yeah, that's true. That's true. But yeah, JavaScript is annoying.
I think what the issue is like our debugging skills do not transfer to JavaScript for the most part because of the way that we tend to do things in a typed environment. And I would love to actually sit down and talk with somebody about what their patterns actually look like. For
maybe we should get David Neal on JavaScript.
That'd be a good idea, actually.
Yeah,
talk to him about that.
Yeah, that's true. That's true. Saving money is hard, especially if you keep jumping out of airplanes because that's expensive.
Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
Yeah, and just like us here at Complete Developer Podcast, he focuses on helping you not only to establish a real financial plan, but to take action on that plan so that you can live your best life and jump out of as many planes as you want.
Right. Investing in financial planning services really comes down to whether or not you can improve your finances with the help of Level Up. The compounding impact of making better financial decisions will easily pay for itself over time.
And the nice thing about Level Up is they have a unique pricing model that will help you no matter where you are at in your financial journey. The thing about that is a lot of people think of financial advisors as people who like sell them financial plans. That's not Lucas. As a financial planner, he is a fiduciary for his clients. So he's not here to sell you a product, but to guide you to a better financial solution.
And you can find more resources and learn more at levelupfinancialplanning.com. Back in my day, no, really, back in the old days, and it wasn't really that long ago, and still kind of persists in a lot of apps now, software installation, especially on servers, was absolutely nightmarish to deal with. Not only did you have to deal with massive installer programs and piles of documentation to get something working properly, but it tended not to be a repeatable process, at least in automated terms. If you installed software on multiple servers, there was a good chance that one or more servers were improperly configured, which tended to result in wasting a lot of time troubleshooting when something went wrong just on one of them. I know that one from experience. Additionally, it meant that scaling out was a lot harder and required a ton more work. And this tended to mean that companies would spend a lot of money on hardware, ahead of time, essentially, simply to avoid spending even more on salaries when there was a need to scale out a little. So they'd buy 10 times as much hardware as they needed right now because they projected that they would need it in a year. And there was a long cycle to get it ready.
However, tech has evolved. Rather than treating servers like pets that have to be carefully monitored and cared for, we now treat the machines like cattle. They are interchangeable, easily added to or removed, and we can quickly get things working in a new environment, at least compared to how things used to be. As part of this process, we've changed our approach to how we deploy code at scale. First, we started with virtual machines so that we could abstract away the underlying hardware in our applications. While this helped considerably, it wasn't enough and wasted a lot of resources on duplicate functionality, like operating system installations and so forth. As we moved further along, we started switching to container-based approaches, preferring to abstract away everything but the operating system kernel.
Now, before we get too far into all this, there are some terms that we need to discuss kind of quickly, just to get some definitions around some stuff. The first one is a container, and a container is used to host a chunk of code in an isolated environment that only directly interacts with the operating system's kernel, maybe a few other things. Basically, it doesn't do much and it doesn't touch the rest of the system. An image is essentially a template for a container. So the way to think about this for developers probably is to say that an image is like a class and a container is like an object. If you think about that relationship, I mean, that's close enough for the purposes of the show, but that is not sufficient for an actual certification test if you go for a Docker cert. Now, images are built up in layers, so you can compose functionality for a new image by utilizing a set of other images, including some that you build yourself. Now, what this ends up being is like you have a image for like Postgres SQL or something, and then you might have some tool on top that uses that. And under Postgres, you probably have some kind of Linux build environment that it needs. This just kind of lets you build stuff up where the pieces are small. Images are available from image hubs. That's like Docker Hub, where they're versioned and where documentation is available on using them. And finally, the host is the machine on which the containers run. So that's your personal server, your work server, or whatever.
In this episode, we're going to discuss some of the general areas where containers can help you in your development process. While we won't get too far into the specifics, we'll probably save that for another episode. We will be talking about some of the features that containers can bring to the table and why they are important.
Yeah, and the first and probably the most important is the isolation from the rest of the system, except for the kernel, the operating system. And what this does for you is this means that each container has its own copy of the very small set of things required to run itself without other stuff in the mix. This tends to keep things smaller and shrink the attack surface area for that container at the least.
Due to each container having its own copy of any dependencies, you don't have to worry about an update or something in another container breaking what you're doing in a set container.
Yeah, and I think that's something that's maybe lost on people that got into software development more recently. But back in the day, you could update something and I don't know, you update a little dinky app that you use for making zip files, and it updated the Visual C++ runtime libraries. Well, everything on the box was pointed at the old one, and now it's pointed at the new one, and some of the apps aren't compatible.
Yeah.
Like you had a very real problem with, they called it DLL hell. And we tried to solve this on the Microsoft side with, the assembly stuff and the, all the GAC stuff that's in .NET.
Mm-hmm.
Kind of sort of worked in places, kind of sort of didn't work in places. But this actually completely separates the stuff out. It's everybody gets their own copy. There is no central repo that container is talking to. This also tends to put a security boundary in place. So if another container is compromised, it's less likely to be able to compromise your container because it doesn't have access to this container's stuff, and vice versa, right? If it compromises the hosting OS, then yeah, that's a problem. But cross contamination is less likely.
Next is the ability to control resource usage. Along with security boundaries, you want to make sure that one container can't use a denial of service for other containers on the machine, intentionally or otherwise.
Yeah, and this is something you run into with any kind of shared environment, even within a business, where it's like, hey, everybody's on the same team. One group could really write a crappy app that chews up the server and everybody else's stuff gets slow, right? Like this is what we run into even on our podcast website. Like if I want to export all the episodes out of our site, for instance, I can only do that on the weekends, usually early in the morning, because it times out during the week because there's other people on the servers that are chewing up enough bandwidth enough CPU probably, that gets slow. So this lets you kind of lock stuff down where that doesn't happen. So your modern container technology allows you to limit how much RAM, CPU, network traffic, disk IO, that kind of stuff that a container is allowed to use. And this will basically keep a rogue container from taking down your server. It also really helps a lot when you have to troubleshoot stuff because you can see which container is misbehaving because it's the one with the problem. Right? Because it runs into the resource limitation instead of screwing up everything for everybody else.
Yeah, that makes a lot of sense. So the next one is the ability to scale out in a repeatable fashion. So container technology is designed to facilitate horizontal scaling. Rather than simply throwing more resources at a container, you can do this, of course. It makes it easier to quickly spin up more instances as they are required. So you've got your image here of this is what goes in a container. You can just quickly spin up more instances of containers as you need them and then destroy them when you no longer need them.
Yeah, and the real key here is that you could do that a lot quicker. And so you don't have as much lead time where you have to buy server assets ahead of time.
Yeah.
So a lot of developers don't completely grasp this, but when you're spinning up new containers, most of the time what you're doing is you're actually you're increasing your expenses, right? And in an accounting sense, that is one thing versus a capital expenditure, which has to be done ahead of time. CapEx type stuff gets a lot more regulatory attention. It gets a lot of auditing and those kind of things in the mix. It gets a lot of other people's hands reach in there to control that versus an expense within reason. And so it's also easier from a process perspective to spin more of these up.
Obviously, this is only going to work to the degree that the code in the container is built to scale outward.
Right. It's surprising what you can get away with.
Yeah.
But I've seen some stuff that is like, hey, that's not a real sound approach. And the containerization made it where they could get further before it exploded.
Mm-hmm.
It's like greasing the rails. The train goes faster, but it doesn't stop as quick. So you do have to kind of be aware of that. The other fun thing about this is this scaling ability can also make it easier to onboard new developers into your team. So instead of spending a day or so trying to manually configure their environment, they can just basically spin up a set of containers that do the work. So, their database instance is there. Web server hosting environment is there. In fact, it's potentially spun up every time you do a build. So you can change it, as you go along. And it really makes it a lot easier also to keep everybody up to date if that travels with the code. We'll talk about that here in a minute. So the next advantage is, well, kind of more of a piece of functionality, but this is how you keep all the stuff working. You're able to mount file system objects, directories, individual files, etc., inside the container. Because the container is an isolated unit, you're probably going to want to persist the stuff that it's doing somewhere. Given that it's isolated, you got to put that stuff somewhere. It's either in a database or it's actually in the file system or whatever. The idea here is that you want your data to be persisted off to the side where when you blow away that container and you recreate it, it doesn't damage anything. I had to do this recently on my network attached storage using SyncThing because I had updated SyncThing on all my other stuff except for the NAS, and the NAS was so far behind that it couldn't talk to the other machines anymore. And so I actually had to go in on the shell because I kind of did something stupid when I configured it initially and I didn't mount a directory for it. And so I had to move that config out using the Docker shell, put it somewhere else, destroy the container, recreate it, but then mount that file system in the same place, essentially. And I was able to spin it back up. And I had to destroy it again today because of some other dumb things that I didn't do. And that was real handy.
Yeah, that makes sense. The app running within the container doesn't need to know about things in the file system outside of the container. Essentially, what you do is mount a file system location on the host path within the client container.
Yeah, so in my instance, it was /var/syncthing/config was what I had to mount. And I just had that shared off to the side in another directory on the NAS off the root. Where I could back it up and where, I could do the whole ghetto backup thing where you copy and paste it somewhere else just in case you screw up and you can recover, which I did screw up. So it was really handy that I was able to do that. That does make it a lot easier. If you think about what used to happen in the, back in the day, you would copy those things off and then you might have to manually edit configuration and stuff in a bunch of different loose files all over the place to get things to act right.
This can also make it a lot easier to do backups. Move your container to another physical device, or simply upgrade the container to a newer version.
Yeah. And what's funny is I wrote, there's actually a show note comment here that's hey, Will can talk about having to do this recently. I have done it 3 times since I wrote that comment. Sunday. It's Tuesday now. And I got it working like I want now. And that actually really helps a lot. Getting that stuff outside the container persisted is very, very helpful. Another thing that is also helpful is you can remap network ports from the host to the container. So I can say, hey, this port is exposed on the container and there's some service sitting here. Well, I don't like that port number for whatever reason. Let's say they're using, 1194, right? And that's your VPN access point. Well, I can't expose that on the host because something else is taking that up. So I could say, put something else there. That way, even if the app inside there is so crummy that it doesn't let you configure that, you can still get around it, which is super duper helpful. This basically lets you forward traffic from the host to a container. But the other thing it lets you do is say, okay, I'm not going to forward this traffic. You got some port that you want to expose and I don't want it exposed because you've included some management interface that's hackable. Just say, no, it's not going to be exposed. Get over it.
Yeah.
And so it gives a lot more control to your sysops type people instead of the developers.
Oh, because a lot of applications use default ports and some of them don't make this configurable. Running inside a container means that you can give the application a different port on the host with the application not really caring about it.
The other thing you can do is you can specify whether you want to map all traffic or just TCP/UDP. You can disable traffic. Now, this doesn't completely air gap the container and its contents, but it really does make it a lot harder to get to, especially accidentally, which is often important.
So next is the ability to configure the network between containers and the outside world. If you're running multiple containers or any container that you'd like to be secure, you probably will want at least some of the containers to be able to communicate with each other while not allowing everything on the network to talk to them. There are several different types. These examples will be from Docker.
Yeah, and that's mainly just to give you an idea of what kind of stuff you can do. For instance, you might use a bridge network, which is usually used when applications are running in a standalone container that needs to communicate with stuff outside. A great example of this is a database server instance. You map someplace on the volume for the database stuff to go, as we talked about in the previous point. You also map some network ports so that apps and other devices on the network can communicate with the database server. But there may be a case where you go, hey, I want to spin up this database server and I don't want anything from outside the host going here, but I have this other container that I want to bridge over to it. And so there's kind of different ways you can do that. The simplest one is, like I was discussing, was the bridge, where you just go, hey, it's open a port on the host, it pipes it on in. And that's fine. The next option is what they call a host network. And you can say, hey, the hosting OS goes straight to the container, all the things, which is the stupidity I did the first time I set up SyncThing. Because I was like, oh, I think this is the only one of a few things I'm going to have on here that's going to be in a Docker container, because at that point I wasn't as familiar as I needed to be really to be trying to do that. There are like 4 or 5 ports and I was having some trouble configuring it. And I'm like, you know what? I'll just put it as a host and just everything goes there. Done. And it did make the problem go away until it became a much bigger problem a couple weeks ago. Not so much. But it is handy if you just need to get something spun up, or if you're, hosting, something else that really jumps around a lot in ports. It opens up all kinds of different ones and all that, and you don't have like a static set that you're mapping.
Yeah. So Mac VLAN networks.
Mac VLAN, yeah. I've heard it pronounced both ways though, which is really screwy. Just as an aside.
Yeah.
I feel like Mac VLAN would be like, some guy that like dies early in Highlander.
I don't know, like
there can only be one network, and it turns out that this network just had a what do they call it? A segmentation.
Yeah. Well, just to quote a little psych here, I've heard it both ways, but these let you assign a MAC address to a container, making it appear as a separate physical device on your network. Now, this is useful especially for legacy apps that expect to be connected directly to the network.
Yeah, so like a lot of legacy apps make assumptions about your network infrastructure and how it's laid out, especially if they're really old. And a lot of times you'll find that you can put those things behind another device and they don't work at all. It's rather amazing how poorly they work. And so in that case, you want to just go, hey, spoof this where the thing thinks it's on the network and that it's got control that it really doesn't have. It's basically like, hey, lie to this container.
Yeah.
And that's really what a lot of this stuff is how to lie to apps from a DevOps perspective in a way that you actually do DevOps.
That makes sense. So next is the ability to control security in the container in a way that isolates it from other containers and keeps it from compromising the host. You can run a container as an unprivileged user, which reduces the risk of privilege escalation attacks from within the container.
Yeah, and you can also map users, such as root. The container understands that, hey, here's the root user. Well, it may not be the root user. It might be wget, at a lower priority or a lower permission set, pretend I'm root. And yeah, you're root within that container, but you're not touching anything outside.
Yeah. Between this, the networking options, uh, private VLAN capabilities, and the ability to limit resource uses, you are more able to trust containers that might otherwise be a bit more risky simply because you can limit what they can do. While this doesn't give you free reign to download every dodgy container that you find on the internet, I'm just saying don't do that. It does reduce the risk of a breach caused by a third party.
Yeah. Or for instance, if you have a WordPress container and one of the plugins gets breached, it would kind of stink if it was able to get out and, say destroy your home network, because that's also your domain controller. You don't really want the Hello Dolly plugin or something on WordPress to like hose your home network. That's in addition to being a lot of work, I feel like people are going to point and laugh.
Yeah.
Because I would. And you don't want to be in that position.
Yeah. Bear in mind also that even if you trust a particular container right now, the next version may have vulnerabilities or even be the result of a supply chain attack.
And I saw you twitch just then because Beej remembers the magical
yes.
time that we had with WordPress. And yeah, we kind of beat the drum about WordPress. Anything with a plugin architecture is going to have this problem. And a lot of things without plugin architectures that auto update are going to have this problem. But basically what happens is you have a plugin, you screwed up and you trusted it. And that was totally fine, worked great. And then somebody else takes over the repository for that plugin and they push a malicious update that does something else.
Yeah.
Either through a breach or like legit, they just bought the company and they're a piece of crap that feels like infesting their users with malware. And this thing gets pushed down.
Very likely given some of the stuff I've seen with ransomware lately, I could legitimately see them going, hey, it's for them being worth buying the company and then sending this out, because probably not going to hit everybody, but it's like a investment risk.
Yeah.
They're expecting to get a higher return than what they spent on buying the company.
Well, and they definitely aren't going to jail for long enough to make up the difference. So, yeah, it's definitely a rising threat, just across the board with, package management systems in general. So you obviously want to get ahead of this before it starts causing you problems. And this is one of the ways that you might be able to do that. Now, containers also let you isolate environment variables and secrets per container. We talked about how they can store data and they can receive commands from outside over the network. But the thing about it is you still have to configure these things. And you want to be able to configure settings within the container itself without having to shell into the container and mess around with the command line in there, which you can do, by the way. But that's not a really sustainable way of going, here's my, root database password, necessarily, when you're spinning up a new container and, running into all those kind of problems. The other thing is you want this stuff stored outside the container so that you don't have to rebuild the container image every time you want to make a change or have some way of exporting that stuff out. Like you want it separate from the container definition, essentially.
Now, an industry standard way of doing this is to supply environment variables to the container. And these variables will be accessed by the code within the container to determine how things should work at runtime.
Right. And you can also supply configuration files from outside the container and have them mounted into the container, which is what I did on my sync thing setup, because there's enough junk there that's like, I'm not doing this in environment variables and I might not even be able to. This lets you manage configuration outside the container itself for a bit more flexibility and stability and those kind of things. The other thing in the mix here is secrets. So cryptographic keys are a great example of this. Root passwords are another great example of this. You probably don't want that stuff sitting in an environment variable where somebody that gets onto the box can go and look at the container stuff if you didn't lock it down sufficiently and see, a root database password. or cryptographic key that's used to protect company secrets, right? Like that's horrifying. And so the container tech will actually let you deal with some kind of structure for keeping secrets outside of the container and outside of the environment variables. It's still accessible from within the container. There's API stuff that basically you can do in there, but it's not openly exposed. And getting into how that is secured is a bit more complicated. I don't really want to do that here, but that is definitely a thing that happens that you're going to want to be able to do.
Yeah, I mean, I've seen it with this, and it's interesting to see how that can be set up. There are different. I don't know. Like you said, too much to get into right now, but yeah, it's interesting.
Now, one thing that isn't so much of a feature, but a design pattern or philosophy, I guess, if you will, is that containers are constructed in a very, very minimal sense, and they're put together using composition to do more complex tasks. So a lot of the stuff that we think about when we're designing object-oriented systems kind of comes into play here. It's like, hey, don't make it do something it doesn't do.
Yeah, that makes sense.
So it's sort of a single responsibility principle type setup, except instead of an inheritance hierarchy, I guess you do kind of have an inheritance type thing, but it composes the pieces together. So, for instance, if you're not experienced, you might try to create a really bloated image that has all the stuff in there that you might ever need. And that's not really the way you want to do this. You actually want to start with like a really small image. So like a Linux image that gets you enough where you can kind of do basic kernel things, and then you put other stuff on top of that. And so like if you were to break down a Docker container, it's actually a series of layers, including whatever your stuff is that's in that topmost layer. It's odd to think about because you're applying object-oriented design type thought processes in a place that there's not objects really.
Yeah.
But if you think about it kind of like that, it makes sense because you have a sort of single responsibility principle. You don't have Liskov, right? I say that, but it's not entirely true, right? Because your configuration in your surface area, that's the plugs for Liskov. So like if I destroy a container and recreate it, and something else is talking to that container or anticipates talking to it, that other thing doesn't know. And so it is kind of like that, but it's not objects. So it's not those principles. But if you think about it that way, that may help you reason about why things are the way they are. Now, this really slim design means that it's easier to patch container images quickly because there's a smaller area to test. So they can do a fix on one layer of it and you just rebuild from that layer out. Because everything below that's okay. Everything past that is maybe or maybe not.
Yeah. Now, containers here, they kind of contrast to things like virtual machines, which have a lot, like a OS load full of functionality within them. This bloats their size and makes patches extremely time consuming.
Yeah. Well, I don't know anybody that's done this. Imagine how long, for instance, your Windows 10 updates take, right? Sometimes you reboot your machine and you're out for 45 minutes, right? Now, imagine you have a setup where you have 10 of those on a box and nothing in your company works until they're all patched.
That's obnoxious.
Right? That's what they're trying to avoid here.
Yeah.
And hence the whole composition model. And so you might just patch one thing and then all the other stuff is kind of rebuilt on top and redeployed. And this is sort of hard to talk about in those terms because it doesn't completely fit with the way we usually look at stuff. That'll get you the feel of it, I guess.
The smaller size also makes things like packaged registries much cheaper to implement since less bandwidth and storage is used.
Right. So like I can go to, Docker Hub and I think I can download 100 images an hour or something.
Yeah.
Before there's a problem. Now they're all split up. And so if I download one, I think I get, dinged for everything that's composing it. And so you do have a bit of a limit there. But in practice, until you're good enough to actually need that account, you probably aren't fast enough to need that account either.
Yeah.
At least so far I haven't been. And if I can't break this particular anvil in this particular sand pile, I question whether a lot of other people can do it either. I'm pretty good at like slamming into limits on stuff, just
Yeah.
by stupidity. It's not like it's some kind of skill. It's like, no, I'm going to do something dumb early 3 or 4 times in a row and then learn from it.
Yeah. What, $700 from it? Was it Microsoft Azure bill?
Oh, God. Don't remind me on that one.
So, guys, next is the ability to declaratively specify configuration for operations and keep it in source control.
Right. So back in my day, we had to write like wiki entries or README files or something even worse to say, here's how you deploy the thing. You install it. Here's the environment variables you set up. Here's, the permission set it has to have. Here's all this other crap, right? And your ops dude, it was always a dude. It was always a dude with a neck beard who smelled like cigarettes that had to do this, right? And if the dude had to do it on multiple servers, it took a lot of time. And so every time you pushed out an update, there was a whole lot of overhead. And so you were encouraged not to push out updates fast or very often and to really, really test everything excessively before you rolled it out. Well, with the whole agile and the continuous deployment and all this other stuff, like you can't do that now. So that dude needs to have some way, and now it's it's dude or dudette or it's like a little bit more open than it was in the 90s, I guess. And they probably don't all smell like cigarettes like they did back when I was coming up.
No, they smell like vape. So
yeah,
strawberry
exactly.
kiwi or something. I don't know.
Yeah, like kiwi flavored. Yeah. So they're all in the server room, and they're also having to do this to multiple machines, right? Like it's not just here's the production server. It's like here's the 30 servers we use for production. And, those are going up and down all the time. And, they're in different locations on Amazon, or they're in different data centers. There's, it's a bigger world. And so they have to be able to do it quick. And so if you declaratively specify a configuration, they can do it quick because the machine can essentially read that and go, okay, here's the crap I need to set up. And there it is. It's live. And that makes it a lot easier. The other fun thing with this is that you can actually go back in source control and go, hey, this has been a problem. These servers have been crashing for a while with some security issue that just comes up, once in a blue moon. You could go back and say, oh, hey, somebody changed this 8 months ago. And, here's why they changed it. That didn't fix it. And I can actually tell that from source control.
Another area that this can benefit that you may not be thinking about is it can actually improve your onboarding process by making it a lot easier for new developers on the team to quickly spin up an environment.
Yeah. And, that's probably kind of understated, honestly, because bear in mind, this is your first impression that you're making really with the developer as far as like your company's professionalism, your company's capabilities. If it takes them 3 or 4 days to set up their environment where they can actually write code, that gives one impression of the kind of stuff you're writing, the way you handle things versus, oh yeah, set up Docker, spin up all the stuff. All right, you're good. You basically pull from Git and run.
Yeah.
Like when you can do that, that has a completely different impression that it gives to those developers. It's also not going to start off their first week with them being frustrated because, bear in mind, they're also doing HR paperwork at this point. Right. So anything you could do in that area is helpful. I say this as somebody who's been doing HR paperwork this week, like going into ADP. But by the way, like they got this message, man. I gotta call this out because it kills me every time I see it. They have a message where you try to save like your timesheet and you've already saved, and it pops up with a little message box that says there's nothing to save. I'm like, thank you, Eeyore. I really wanted a little more gloom in my life. Thanks, ADP. The message just Cracks me up.
Like what, like 4,222 saved, no survivors.
Yeah, exactly.
I think that's the right number. I don't remember. It's been a while since I've seen that episode. But yeah. So also with this, since you're running the same environment configuration on your own machine, there are fewer things that could cause your code not to work when it's rolled out to production, because a lot of the configuration issues are not going to be a problem because it's going to be the same setup.
Yeah. And thankfully, developers never say, well, it works on my machine. Use that as an excuse. I mean, I don't know anybody that does that. But if they were to show up, this would prevent that, right?
Now, using that as an excuse is one thing. Using that as a, all right, that limits where, like, that helps narrow down where the problem is different. Because I have used it like, well, it's working on my machine, so that narrows it down to something like a configuration or something like that, and that told us where to look. So I guess it depends on the reason you say, well, it works on my machine.
I just do it to troll people. I mean, let's be honest here. That's the reason. That's the reason I do most things.
Yeah, I was saying, like, that's like the only reason you do almost anything you do. So
yeah. But the other thing is it forces the developer to actually effectively document in, the configuration in a way that it is repeatable, because they can't work if they don't.
Right.
It's funny how quick we'll act right when we can't get a paycheck otherwise.
Mm-hmm.
So it's very, very helpful. It also makes it a lot easier to quickly and horizontally scale your systems without necessarily involving the development staff or staff at all, right? Like, you can set things up and go, hey, when I get under a certain amount of load, spin up more servers and use this Docker stack and spin this crap out and have another box ready. And you could dynamically scale that way. And the ops people don't have to call the developers on the weekend. Can you imagine? Like, I mean, I feel sorry for people that have to do that, because can you imagine calling some surly, half drunk developer on a Saturday night that's July 4th because the server's gone down and, due to load, and you need to spin up another one and you've got to ask them about config?
Yeah.
I mean, that's really not good for employee retention. So like this is a pretty valuable feature in my opinion.
Yeah. Yeah. So finally is the ability to package a complete application in a way that it would work when deployed, including dependencies. And we kind of talked about this in the previous point a little bit too. But what this means is that deployment is a repeatable process, and you will have fewer false positives from QA because of configuration issues.
Yeah, because QA, if they're doing their job, they will find those.
Oh, yeah.
Like, if you're doing your job poorly, you'll put them there. And if they're doing their job well, they'll find them. And,
exactly. Yeah.
That's not a helpful dynamic. It's helpful for keeping stuff from getting out to production, but it's a lot better to not have the problem and not to have that conversation.
I just love it when, like, I used to get frustrated with QA. And it might have been the particular QA I was working with. Just, I know I've complained about him in the past, but after that project, the QAs I worked on, they were really good. And the last one, she was so great because it was mostly just an API. It was a very little lightweight front end, but it was like I was building an enterprise service. And so a lot of her stuff had to do with testing through Postman, and she wasn't familiar with doing that. And so I remember this one time she asked me to hop on a call. She's like, I'm really confused by this. I think I'm doing it wrong. And she showed me. I'm like, nope, you are doing that absolutely right. You found a bug. I'm like, I didn't test it that way. It's just something I never even thought of. And so, yeah, well, yeah, that's a good QA, is someone who does that.
Well, I mean, I've had the experience of somebody pushing something out. It wasn't me, and they copied a config file over wrong. And so it's trying to hit a server it doesn't have access to in the QA environment, and everything's failing. And it's like, oh, all these tests failed. And it's like, well, no, we just did something stupid with our config. Avoiding that problem kind of cuts down the friction between devs and QA, because the devs get mad at the QA for not understanding what the problem is, and the QA gets mad at the devs because the QA just had their time wasted.
Yeah.
And management's mad at both of them because they're not effective.
Exactly.
And they're arguing all the time, and they're coming to management with a problem. So it's bad all around. Another thing this lets you do is when operations rolls out an update again to the container, they can keep the old container and roll out a new one with the changes. This means that you can roll back to a known good configuration in the event of an error, or at least do so more easily, right? Like if there's some cases where you're going to have to be careful about this, but this is really helpful for things like Sarbanes-Oxley, right? Where you roll out and you've got to have a plan for how you're going to roll back if you screwed something up. They're not going to accept that, you did it wrong. And this makes it easier on the ops people. I mean, I had to do this last week with my setup and, keep an old container around disabled for a while to go, okay, does the new one actually work? Like, did I screw up anything? Did I had to basically unit test it and all that. It's helped. The other thing that this does, as the configuration rolls out to developers, this makes it easy to switch configuration when you switch branches and to do so transparently. So if you are rolling out config changes in a new branch and you have to go do a bug fix, you haven't busted your system yet. You stash and you switch branches and you go. And when you encounter real software development, you're going to encounter a lot of bugs, and you're going to be real happy that you have this. I mean, I've seen situations where people had to, like they would back up their Windows machine before they made a major change, and then they would restore the machine if they needed to switch over to do bug fixes. Like that's what we had to do back in the day in some cases.
Wow.
Yeah. And it's unbelievably awful. And so what they end up doing is they don't change configs either, because it's so expensive. You can't afford to do something that only provides a little bit of benefit. And so you can't get benefits to snowball when you do that.
Yeah. That makes perfect sense. Like, and just dealing with configs in general is a major pain.
Yeah.
And the fact that using containers makes it so that you don't have a lot of those pains, or like, I don't know, it's the ibuprofen for it. It dulls it a little bit.
The other thing is it blows up in the faces of the people most likely who have the ability to actually fix it. Right. So like if there's a database connection error or something and, it blows up on me as a developer, I can troubleshoot that, especially on my local machine, versus, it did it in production. And, here's the ops guy out here, and it's at night, because we also, if we're not doing this kind of approach, we have to do changes at weird hours so that we don't take the system down for people because their scaling's messed up and everything else. It changes the whole approach essentially. So guys, containers really clean up a lot of issues that developers have been fighting for years. And by years, I mean decades. In particular, they get rid of a lot of the configuration and setup difficulties that used to be commonplace when you roll an app out. They push them back. Like they're still there, but they're not in the same place. And it's an easier place to deal with them. Additionally, they make deployment and operations concerns a first-class part of the development process, which can have substantial impacts on the speed and quality of development work. Finally, container technologies also let you store configuration alongside the code that requires it, substantially improving change management. Pretty much wraps us up. Beej, what do you have this week for us for tricks of the trade?
So guys, I want to talk to you about learning concepts behind the code and why learning computer science concepts is important. We often complain, or if we haven't been to college for computer science, hear complaints about colleges teaching only the concepts and not the practical skills. I know Will's talked about that. I've had other people, junior developers I've worked with over the years, have complained that, they went to college, they spent 4 years, and they got a little bit of coding in a couple of classes, but they didn't really learn the skills they needed to get a job. And like, it was a struggle for them starting out. Coding boot camps are full of college graduates looking to learn practical skills. Will and I have spoken at Nashville Software School and a few other coding boot camps that like a good chunk of the students are like they've got a degree. They just got out of school, got a degree in computer science, and now they're going to a boot camp to learn practical skills. There are other ways of doing that, but the thing is, jobs no longer want a junior developer who knows the concepts but doesn't have usable skills. They want to be able to put those juniors to work almost immediately. Now, for those of us who didn't go to college for computer science, the rush to learn the skills can cause us to not take the time to learn the concepts behind the syntax and the practices and the languages that we're learning. Learning the concepts allows us to be able to apply what we learn in one language or framework across the board to the next one we learn. For example, I've been doing a lot of C# and .NET for the last, 4 years? Like I did some Angular before that, but I've been doing that for probably the past 4 years or so, with very, very minimal amount of JavaScript and Angular work. And now I am leading a team doing front-end development. And that is very different. But because I've taken the time to learn the concepts of, going back to school for it has really helped a lot with that. But, and the podcast too. I mean, if you're listening to the podcast, you're kind of already one of those people who likes to learn the concepts because we do talk about them a lot. But I just want to reemphasize the importance of that because it's helped me to be able to make that transition quickly, to move from being a C# developer to a TypeScript developer. And not just that, but understanding those concepts has allowed me to come in and mentor people who know a lot more of the front end development than I do, but they know a lot of the syntax, but not the concept. So I can say, okay, how would we do it? Here's what I want to do. How do we write that in code? And it becomes a teachable moment for both parties because I'm learning how to actually implement the concept and they're learning the actual concept. And it's really great. So knowing those concepts it helps you grow as a developer. And once you've got the actual coding skills down, it can not only cause you to be able to translate those skills across languages and platforms, but also can help you grow your skills. That's pretty much all I've got. I also want to invite you guys to check out the aftercast for this episode where we're going to talk about some best practices for horizontal application scaling and monkeys writing Shakespeare. I mean, Chaos Monkey. I knew I'd get a laugh out of Will on that one.
Yeah. The thing is, if you get an infinite number of monkeys with typewriters, you actually get Facebook.
Oh, my bad.
Yeah.
My bad.
We tested it.
We
proved it.
All right, guys. That's pretty much all I've got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.